Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Well, hello there, and welcome back to, or if it's your first time, welcome to the Digital Enterprise Society podcast. Thank you for coming along on the journey of this show that is dedicated to be a resource to those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to co-host this show every week with Craig Brown, an industry veteran and a former PLM leader at General Motors. Craig, how are you today?
I'm great. Things are wonderful here in Southeast Michigan. It's pleasant weather this week.
You know, you always do this to me. We've been recording these all summer, and I'm in Austin, Texas, where it was 107 yesterday. And you always throw out these like 79, 80-degree temperatures. You know what? If you're not living on the sun, you're not living.
It's only 73 today.
Well, we're actually going to be together soon at Connex in San Diego, where it's going to be perfect weather every day, because that's what San Diego is all about.
Okay. Well, I've never been there. I'm looking forward to it.
Oh, you're gonna have fun. We're gonna have a good time in San Diego. So each week, Craig and I try to bring to this podcast interesting interviews and other ideas to help all of the listeners enhance and grow their careers. And today is no different. It's going to be great. Today we have Dr. Mike Grieves. Now, he is the Chief Scientist for Advanced Manufacturing at the Florida Institute of Technology. Hey, Mike, welcome to the show.
Thank you very much.
Hey,
Appreciate
Mike.
it.
Hey, Mike. I don't read like the bios that like the marketing department for Florida Institute of Technology would send me. I like you to share with the audience. What's your backstory?
Sure, happy to do that. So I have been in the computer industry for a lot longer than I would care to talk about. I started basically back as a teenager in the 60s, being a systems programmer on mainframe systems, and basically running operations for a Fortune 200 company in my early 20s. So a lot of broken glass as I figured out how to manage things. But I got to do some really cool things, including running the most advanced computer in the world, the ELAC 4. But I basically moved on from that to become an entrepreneur, started my own computer companies, and the last one I started, I took public in the mid 90s, and had built it up to $100 million. We were in business of computer integration and large scale networks. And I went back and got my doctorate from Case Western Reserve in executive management and systems. And then, in fact, stumbled onto product lifecycle management through Craig's old company, General Motors, when EDS had approached me in the early 2000s and said, you know, you're talking about this idea of using information in exchange of basically making a lot of mistakes. You know, we're looking at this thing called product lifecycle management, and could you do that? So I had joined the University of Michigan at the time, and had given some talks on basically, hey, if we used information as opposed to simply try to take advantage of suppliers, we'd have a much better opportunity. And so got involved with that. Wrote the first book on product lifecycle management in the early 2000s, but had created this idea that was behind product lifecycle management, which is this digital twin, which is the idea that I can take information and strip it out of products and basically use that information. So I wrote the first book in about 2005, 2006, and subsequently moved to the Florida Institute of Technology, where we do a great job in terms of applied technology. So I'm not so much interested in how many angels can dance on the head of a pin. I'm interested in how we can use this. So consulting for companies like NASA and Boeing and Newport News Shipbuilding, you know, so I get to play now with all the good toys, and I don't have to deal with the accountants and attorneys as a CEO. So it's a win-win for me. So effectively, I retired in 2000, failed miserably at retirement, and this is what I do now. So I am very much involved in talking about this whole idea of product lifecycle management, but the underlying principle is this idea of the digital twin.
Mike, that's great. You and I talked about retirement when I was still in Pontiac and powertrain, and it's interesting now. I think it's about 15 years later. Here we are again. You mentioned the term digital twin, and it's a very popular phrase now at least in the circles of advertising and PLM companies. And frankly, I think there's a lot of confusion. Do you have a definition of digital twin that can clear this up?
Yeah, so my idea of the digital twin is basically it is having the information about a product. That basically, the ideal aspect of it is that any information I could get from the product itself, from the micro to macro level, I can get from its digital twin. So in essence, what it started off as, if I have a physical product, I would like to strip the information off of that and be able to have that information available to me without having to be in proximity of the product. So in the past, let me take an airplane. If I'm flying on an airplane, if I wanted to know anything about that, I needed to be on the airplane looking at the instrumentation. Today, if we have a digital twin of it, no matter where that airplane is in the world, what its speed is, what the turbine blades are turning in, how much fuel it's using, I can get that from the digital twin. But subsequently, I extended that because the idea is that it is not only about actual products that exist, i.e. the digital twin instance, okay? So when I build an airplane or an automobile or a nuclear carrier, I want to have exactly how that was built. But it's also the potential of a product, because when I thought about it is we really don't walk into a factory, pound some metal out and say, gee, I hope an airplane comes out of this. We basically have that, we basically create the information, the digital twin of it, well in advance of the product itself. So I've extended back and I call that the digital twin prototype. But we also have sort of the ability is when I have a whole bunch of these things, I can basically take all the digital twin instances, so all the airplanes in my fleet, pull them together and basically collect information on them so that I can basically do things like predict failure. So as I always kind of say is, as a frequent flyer, I do not like an engine failure at 30,000 feet. I don't even like it when it's at the gate because it means I'm going to be in for an extensive delay. What I really would like to do is basically say, gee, when you see these sort of characteristics, you replace this unit, the next time through the maintenance hub and you never have a failure. And so that's kind of the focus is three types of digital twin. The digital twin instance, which most people think about, and this is where the confusion is that I have to have a physical product attached to it. But the precursor to that, which is the digital twin prototype, which is the information about what I'm going to make out of the product. And then the digital twin aggregate, which is basically all these instances and their experience that allow me to basically do things like prognostics, inquiry, and even machine learning.
Yeah, we had a recent example in the car business around all these electric vehicles where in sensing the fleet, we could begin to understand the characteristics of battery performance. And, the new technology in electric vehicles is really the power electronics and the batteries, right?
Right.
And so being able to monitor the fleets, this prognostics or this proactive maintenance could be done. And in fact, it actually had the impact of adjusting the digital twin a little bit because there was some physics we didn't understand. And so once you understand it, then you can quickly update your digital twin, if you will, and have it affect not just future product, but also affect current maintenance schedules. So this is one of the amazing things to me about where the computer revolution has gone is just people like to talk about Internet of Things, and they like to talk about all this other stuff. I don't think they appreciate that if you can monitor across the fleet, that you can really help each other, even though you don't realize it, because you can learn from one person's usage and help the next person who might use it that way a year later, right? So it's really interesting. Talking a little bit about simulation, you bring up the term front-running simulations. I think it's in one of your earlier books on digital twin. And then we've got data analytics and artificial intelligence that's just exploding, partly because computers and cloud computing have gotten even cheaper. Do you think AI will have a role in the digital twin? And if so, what would it be?
Yeah, so remember, I get to basically propose these things well in advance of being able to do them. So the first digital twin model was introduced in 2002. And if you basically did a Google in 2015, you might have come across a couple instances of the digital twin, which were probably mine. Today, if you Google a digital twin, you come up with 1 million hits. And if you do digital twin images, you come up with about 500,000 hits. So I was obviously ahead of the curve. My idea of front-running simulation is the idea that when we have enough computing power, which, if you don't like how much computing power we have, wait 18 months and it'll double. But the idea that says, look, if I could basically run a simulation in front of my actual unit, I'd be able to sort of predict the future, if you will. So a crystal ball sitting out there. And so this idea that says, look at, and we sort of have versions of it. So like adaptive cruise control that says, if you keep speeding along these lines, you're running the car in front of you. But the whole idea of being able to sort of predict performance in advance, days, hours, maybe even weeks, but certainly, in vehicles, but factory, situations where basically when I'm looking at the individual units and something has happened, and now I predict out and say, by the way, if I keep doing this, I'm going to run into a big problem, in 15 to 20 minutes, allows us to basically be able to adjust that. So this idea of front-running simulation is we will continue to run simulations with every new tick of the clock at time 0 and be able to sort of predict out ahead because of what you said previously. If I've got all this information about how things have occurred, and I got my physics right, which you were absolutely right to point out, is I should be able to do a pretty good job of alerting myself to say, what I think's happening is not what's happening. So one of the examples I use is the BP the problem with the oil rig. You were getting indications of what was happening, and people were locked into, gee, I think this is what's happening. AI would allow me to basically say, hey, you think this is happening, but here's our predictions of what's going to occur, and you need to basically, pull your head out and take a look at other opportunities. So when we get more computing power, we'll be able to do that.
Yeah, and I think that's what people maybe have a hard time, especially older people. I'm one of those now. You get into certain patterns of assumption, and you just think that's just not possible. And then somebody, typically a youngster, walks up and says, well, I just simulated it with these other variations. You said the inputs were, stable or predictable. What if they weren't predictable? Here's what happens. And, maybe there's a catastrophic failure, all in the virtual universe where it's safe to do that and, understand what really happened.
So as I like to say, it's not the usual suspects that bite you, it's the unusual suspects.
Yeah, I have an ethanol experience where people said, if the gas pump is right, this is the guy who taught me this was my black belt in design for Six Sigma. If the logo on the gas pump is right, then our control algorithm will work perfectly at sensing whether you're ethanol or gasoline. This is a big deal a few years ago when ethanol was a major fuel component. Well, it turned out, why should you believe what's on the gas pump? And our black belt, he pointed out, he said, well, let's just suppose it's wrong. Let's suppose the guy from the distributor put in the wrong gasoline in the tank. He put in ethanol instead of gasoline, or vice versa. Well, the pump doesn't know because it's a fixed label, right? But in your gas tank, you'll have 50% ethanol, 50% gasoline, as an example. Well, it turned out our strategy for controlling this whole thing with fewer sensors didn't work so well all of a sudden because the guys who designed the algorithm just assumed that what it said on the pump was true. Well, this is a good lesson in systems thinking or design for Six Sigma. You got to know whether an input is a noise or a signal, right? And in the case of the quality, the ethanol content, well, it was a noise, not a signal. And you have to make your system robust to noises is the whole point in design for Six Sigma. So anyways, simulation helps. One other thing, in your first book, you talk a lot about the data silos, and they kind of got formed because of the age that people started using computers. So we have a work order system, for instance, because it was cheaper to do that in a series of laptop computers or desktop computers instead of a mainframe. But the parts management system's often a mainframe, or maybe it's evolved into some relational database now. Those two systems really ought to coexist. They ought to be, the view of the data should be consistent across them. And yet it's really difficult when they're done in silos. Does big data or analytics help solve the silo problem?
Yeah. So I mean, you've got sort of two pieces here. One is basically the siloing of data, and the second is siloing of people. And so
yeah, which came first? I mean,
yes.
right?
Yeah. So kind of the issue of it is that, we basically, and I think the digital twin helps us, is pull information from different sources in order to create sort of this homogeneous thing. I mean, the other thing is we basically drove to this functional perspective, so that the functions and the sub-functions, basically ruled, and we optimize those only to sub-optimize the entire system. And so we needed to take, and why product lifecycle management came along and was so attractive, is we need to take a product-centric perspective, which means basically, instead of siloing this, we need to basically collect it in this idea of the product itself, or the digital twin, or however you want to reference that, and focus on that. From a people perspective, we've also siloed people. I mean, a long time ago, we basically transferred people across organizations to basically give them a feel for the other things. So no, any engineer that hasn't worked in manufacturing, I don't want to work with, because their perspective is, I designed the thing, I throw it over the wall of manufacturing, and I'm done. And so, and by the way, that's my perspective on systems thinking. Also, on the systems group, is we've turned into system accountants. Tick and tie my requirements to verification and validation, and I have a system. Does it work? Oh, well, that's not my problem. Right. So I mean, so I think we've got to basically not only address the data and information piece, we have to address people's perspective of seeing more than what's in their silo to understand where the information is. I mean, one huge problem is recreating information downstream is anywhere from a magnitude to multiple magnitudes more expensive than collecting it at its source. And yet the people collecting at the source may say, well, gee, I can't use it, so why should I expend the resources there? So you have to take this non-siloed, product-centric perspective if you're going to basically be effective and efficient.
Yeah, and I think viewing, and I'm a novice, I'm trying to get to be less than a novice, the data science around bringing together views of context of data from different silos might make it easier to get to decisions than in the past, when you had to literally wander from one silo to another and then put things together in a PowerPoint presentation. I hope this will improve it. And like all kinds of hype, there's an awful lot of hype around big data and analytics as well. So there'll probably be some really bad failures, and then we'll get better at it.
Remember, garbage in, garbage out is still really relevant in today's world.
Well, that's what amazes me. One of the things that amazes me about the silos is they didn't use the same dictionary. And what I mean, everybody, is they use the same words, but they have completely different meaning. And that's a real problem for a computer. Computers are not able to make those leaps, or at least they haven't yet, and do it reliably, right? There's always got to be a human helping do the translation. You've written a couple books. I have them both. I got the second one when I got my black belt, which I appreciated. Thank you very much. Are you planning any other books, or is it time for others to write down your thoughts?
No, so there's been a push to basically put out a book on the digital twin and sort of the new organizations that are using that. And I'm in the process of sort of collecting information to do that. So I expect that sometime in the middle of next year, you'll see a book on the digital twin and 2020 vision, if you will.
Interesting.
I have, as you say, there is some confusion about the digital twin, and I love when people sort of ascribe to me perspectives that I don't have. So I think getting, I have 2 chapters out there that are pretty definitive on not only the digital twin, but the physical twin. Because if you don't have a physical twin, that basically can sense and communicate, you're not going to have a digital twin. So these two things go hand in hand. And so my perspective is putting these things together. So I expect to have something out by mid next year.
Cool. Excellent. I'll look forward to it. I will buy that one as well. And maybe you and I will be on a panel. We can debate it the year after. How about that? So the last thing I wanted to touch on, it's kind of a different thing, and I was actually pleased to see you there. So we were both at Realize Live back in June, and the session that we were both in, or you were a panelist in, I was just a participant in the audience, was on additive manufacturing. And one of the things when we set out the Digital Enterprise Society was these smaller manufacturers, the changes occurring. Some of them haven't adopted some of the computer-based tools because frankly, they're expensive. But then also there's things coming like the ability to print a part that might really change the game in favor of the mid-size and small-size manufacturer. What are your thoughts about that? I noticed that is your focus at the Florida Institute of Technology, and I'm curious to say or to hear, I think our audience would like to hear, where is additive? Is it around the corner? Is it 5 years off? What's Mike Grieves think?
So you have to understand how it sort of fits into my perspective of where the world is, and that is this movement from physical to digital. And so my ideal is that what I like to do is to design the product virtually, test the product virtually, manufacture the product virtually, support the product virtually, and then when I get it all right, basically go out and move around expensive atoms. But as your old colleague at General Motors, Dr. Susan Smith, who was the chief scientist of manufacturing, convinced me is what I really like to do is print them. And so for a number of reasons, I think the idea of additive manufacturing as part of that schema really makes great sense. And so I am very much bullish on this whole idea of basically being able to do that. So where is it? I mean, I think we're within a decade of basically having additive manufacturing even in mass production. I mean, we've talked about mass customization, and products for one is the ability to basically have a digital twin and then print them is going to be where we get that. So I'm always pretty bullish on obviously the technologies. I've been sort of right on where the computer technology has gone. I think that the whole idea of additive manufacturing and materials and things like that is going to allow us to print. I mean, my other big interest is bringing manufacturing back to the United States, and I think that is really the mechanism by which we will do it, is to basically be able. We'll never be working harder, working longer is not how you're going to fix this problem. Working smarter is how you are. And so the ability of basically, being able to create products we've never created before because we can do designs in additive manufacturing, the ability to reduce part counts so that it even makes sense for a company like General Motors to produce a part that they're now basically buying 100 parts and assembling them, and the ability of lightweighting things by basically creating parts that have the same structural characteristics and yet have, say, a third to half material is really key. So I'm very bullish on this, and I think it's sort of part of the whole digital physical twin concept.
Yeah, and I for one think additive a decade for mass production I think is reasonable. I think well, we saw there at the conference there are a couple companies, Siemens Energy most notably, that uses it to repair parts in the field. Now that's just really interesting. You take a part that starts to have a hairline fracture or something, and you use a 3D printer to help repair it. And just that whole notion of a repair, I mean, remember your Star Trek movies and and all those things where you had a laser repairing something, right? Well, if they're doing it with fan blades and pumps and injectors inside of a turbine, the rest of it's just a matter of time until you just get to scale, right? I mean, obviously repairing one at a time is much, much slower than mass production, but this is how it starts, everybody. So I think things like additive printing might well help drive clarity with digital twin and PLM and the rest. It's interesting to me. You can't do these things without PLM, and yet PLM people get confused. At least middle management or upper executive management, which don't have engineering or science backgrounds, they get confused about it. Like, oh, haven't we done that already? Well, computers keep getting cheaper, and things like analytics, data analytics, let you do more things. So it'll be interesting. Mike, I enjoyed chatting with you. I'm glad you agreed to be one of our guests. And thanks again. Congratulations on your promotion there at Florida Institute of Technology. And Thom, I'll hand it back to you.
Hey, Mike, before I let you go, I do have one little thing that I've sort of noticed in hosting these podcasts and having been involved with PLM World and now the Digital Enterprise Society for a few years. And that is the people who work in and around the stuff that you're researching and you're talking about. You said it best in when you were talking. You said you failed miserably at retirement. And Craig is failing miserably at retirement because here he is talking about this. Why is it that so many people who work in this field are so enthusiastic and passionate about what's going on right now? Is it just the speed of change? Is it the way it's going to impact manufacturing in the future? Why is there so much passion and people can't seem to retire?
So I mean, interesting question. I mean, part of it is having ADD a bit, but the other aspect of it is that getting to see kind of these advancements is really very cool. I mean, I can't wait to see the next thing that comes along and be able to incorporate that. So sort of the anticipation of the future is really sort of what drives it. I guess if I was in a business that basically was the same day after day, I couldn't wait to get out of it. But that's not what we're in. I mean, we are in a really interesting time in terms of the ability of using information and new capabilities like additive manufacturing to really change the landscape of how we've done things. So I guess the thing is that it'd be difficult to say, gee, I don't want to be doing this anymore, because how do you get to see what's happening next? In fact, how do you get to have your sort of your impact on it and help guide it? The combination of experience and yet still understand adopting the new technologies is something. I mean, that's the younger generation. Yeah, they understand new technology. Well, they lack a lot of the experience, and some of the older folks who don't understand the technology, as sort of Craig pointed out, are basically impediments because they don't want to change. So if you got both those capabilities, I think it's almost sort of criminal not to use them.
So then this is a good time to be in this business, to be in the digital enterprise and to be working around the PLM and everything else. So are you bullish for sort of the young up and coming people in this space, that they have a huge career ahead of them?
Oh, absolutely. I think the key is that they basically have to kind of look at, all the different sort of capabilities that they need and not get themselves locked into one sort of siloed thing. And so you got to balance this idea of being, I used to be, you could basically be an inch wide and a yard deep. You can't anymore.
Yeah.
So you got to basically you need to have some deep experience in things, but you also have to have a broad perspective of the industry at all. I mean, if you're only engineering, you have no idea how manufacturing works, that's going to be a problem, or vice versa.
Well, Dr. Mike Grieves, thank you so much for joining Craig and I here on the Digital Enterprise Society podcast. We appreciate you. Thank you. So, and everyone, join us next week for more thoughts, ideas, and information in and around the product lifecycle management. The Digital Enterprise Society is the place for the exchange of ideas around the digital manufacturing tools. Learn more at digitalenterprisesociety.org. We're going to be back next week with another great interview. So we'll see you then. Thanks a lot.
Bye.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org.